So let's now transition to the keynote session 2. We have fascinating lineup ahead. Our first keynote is Professor Rob Goverde, Professor of Railway Traffic Management and Operations from TU Delft, Netherlands. He will be enlightening us on the topic of railway operation research for the future automated railway system. Please join me in welcoming Professor Rob.
Good afternoon. I hope you enjoyed your lunch and are ready for this afternoon. So besides professor at TU Delft, I'm also the president of the International Association of Railway Operations Research. And in this keynote, I'd like to present you why railway operation research is important as part of the technology for the future of automated railways and why we need automated railways. So this is a brief outline of my presentation. I consider the various planning and management and control issues that we have for going towards automated railways, and overall show you the digital automated train operation that can be accomplished in the end. So to set the scene, why are we doing this? First, rail is the most sustainable mode of transport and is essential for international connections, national connections, accessibility of big cities, and livability within cities, and that's basically in all the countries. Passenger freight rail demand is growing, while capacity is increasingly saturated, which is specifically true in Europe. But also here, if you really will achieve modal split towards railways, then you might have this capacity saturation that you might not always want to resolve by adding more tracks, quadrupling tracks, but actually exploiting traffic management and train control strategies. So rail capacity must increase significantly to accommodate growing demands. And you also want to do this with high reliability, lower energy consumption, lower costs, and less workload. And this requires high-performing train path slots over the network and time that must be safe, conflict-free, reliable, and energy efficient. And that to do this, this can be enabled by the digital technology, and basically a mix of radio-based railway communication, which is in Europe developed in the ERTMS system, the European Rail Traffic Management System, also used outside of Europe. You need automatic train operation and advanced traffic management systems, and particularly the combination of these. But if you do so, if you really digitalize and automate your railway systems, you also have to revise your current planning and management of the railways, or the railway traffic operations. And that's what my presentation will be about. So the 4 pillars of the digital transformation are automated railway timetabling. On the one hand, you really need to quickly be able to come up with good timetables. You have to keep them viable. So advanced railway traffic management is considered to deal with disturbances, disruptions. Automatic train operation to really run your trains well. And also advanced railway signaling systems to really use your capacity at the top. So I will deal with these 4 pillars one by one and then consider them also together, starting with the automated railway timetabling. So automated railway timetabling, usually you start with some macroscopic timetabling, basically finding your train lines over the stations, where to stop, which routes, etc. And then you come up with this time distance diagram as shown here. So you have time on the vertical axis and horizontally the distance between all kinds of cities on a corridor. But also in stations you have different platform tracks, and you need your trains to run over this station, over all the crossings, the interlocking systems towards the platforms. And that should also be conflict-free and, accordingly to this macroscopic timetable. If you know the exact routes over the network and in the stations, you can actually compute energy-efficient train trajectories, which are basically the speed profiles that the trains can take over the network. And I will show this much more in detail later. And when you have this train trajectory of all the trains, all the speeds, you can actually compute exactly how much infrastructure occupation each train needs in these so-called blocking times. And that is shown in this blocking time picture over there. You see actually the time that it takes for each train to occupy a certain block. And you can then also see that actually the timetable is conflict-free because these blocks should not interfere with each other. They should not be overlapping. And that actually gives a full cycle. Because if you have then these blocking times, there might be conflicts, so you might actually use that to re-optimize your network timetable, and that might take some iterations. So one of the key ingredients of the planning and also the traffic management is the train trajectory. So that's basically the speed profile of a train and the corresponding time distance path. So you can compute the fastest running time, which in this case would be the red line. You have the speeds going up over distance, going to the maximum speed, and it has to brake just to arrive on time or arrive as fast as possible to the end of the track, to stop. Usually there's some supplements in your train schedule so that you can deal with delays, but also you can use it for energy efficient driving. So one way to use the supplement, you basically have to tell the drivers what to do rather than running as fast as possible. So drivers can use the experience to do so, or you can give them, for instance, a scheduled timetable speed that they can keep up, but you can do better in terms of energy efficiency by giving them an optimal cruising speed, and at some point they could start coasting. So in this case, we have a situation where a train accelerates until 1.25 kilometers, and then they can put off the traction, just coast, and in the end brake for the rest of the 5 kilometers so that you don't need any energy at all. So that would be the energy efficient driving. So if you know this, you can also compute the corresponding infrastructure occupation, etc. You can also do this on an entire corridor. To instead of saying, okay, we need, say, 5% of supplement between each stops, you can also compute the optimal allocation of the supplements over the corridor between all the stops, and it might be different depending on the distances between the stops. And this picture shows the optimal situation of a certain corridor with 5 stops. And you see that for the longer distances, there is some cruising speeds, some optimal cruising speed that is below the maximum speed that the train should be kept. And at some point, it will start coasting, where the train stops having traction, and it will just, because of the resistance, slowly reduce speed. And for the shorter distances, it will accelerate once to some optimal speed and start braking, start coasting already until braking just before the stops. So this is a way to actually compute energy efficient timetables, which is slightly different than giving them some norm about, okay, use 5%. Instead of having this kind of norm between all the stops, you say, over all the entire corridor, we say we have 10% of supplement, and the computations can actually compute how you would divide it over the line to be as energy efficient as possible. And when you have done that, you can also compute the corresponding infrastructure occupations that are basically represented by the signaling systems that you have, so that you can see how much time there could be between the trains. And this picture shows you a compressed timetable. If you look carefully, you see that on the left or on the right, these stairways are touching each other at some critical blocks. And that means that they cannot be faster than that. So this should be, this leads to a minimum headway of the trains. And by adding some buffer, you can actually have some actual timetable that is feasible, conflict-free, and energy efficient for all the trains. So this is basically the basis, a good timetable, energy efficient timetable. And if you have that, the trick is to keep this conflict-free during operations. So the start is the conflict-free timetable. Based on that, the routes are being set for the trains. The trains start running, and the train detection usually shows where the trains are, and this is monitored by the traffic control systems. It could also be that the train operators themselves show the train positions, which are monitored, and also you might have travel information where you can also know something about travel choice of the passengers. So from the conflict-free timetable, you see all kinds of operations which are monitored by sensors. And this can be used for conflict detection to see if you expect any conflicts because of delays. And you should resolve it proactively to keep this conflict-free timetable. So just to consider small disturbances, certain delays. Also for bigger disruptions, that might be that some track is blocked, some train is stranded. Then you have to reschedule, basically come up with a new conflict-free timetable so that you keep your traffic running. So as an example of how railway operations research works, this is a simple network with a corridor on the left lines. You see with different colors, different train types. And they're running up and down these lines. I suppose there is some kind of obstruction here where the trains are no longer being able to run. For instance, there's a stranded train there or a section failure. And then you need to come up with a new timetable. So this is typically an optimization model. In this case, we resolved it by trying to minimize the weighted sum of delays and trying to avoid cancellations of trains. And by doing this, you basically get short turns of trains that they come up, try to go as close as possible to this obstructed track and then turn. But because of capacity reasons, it might also turn at other stations. And the idea is that to keep those trains running in some feasible circulations. So if the disruption is over, the trains can run back to their schedule again as quick as possible. So there are usually several phases. The first phase, when the disruption happened, is to transition towards the new situation where there's a new steady state. That's the phase 2. So in the phase 2, you see now there's again some periodic pattern. And finally, the phase 3 is it recovers to the normal situation. And this also you want to have as short as possible to get the trains again on time. A different kind of optimization problem is within the stations. So if you have in the station such an occupation chart, and there could also be some tracks that are blocked. For instance, there could be, for instance, these two platform tracks that are blocked for traffic, and then those trains that you scheduled to stop at those tracks need to be rescheduled. And again, it's an optimization problem. It might be some of different kind of objectives that you want to optimize. And you might have different options to do, like rerouting over the station, replatforming, so go to a different platform, retime a bit, also shunting may be considered where the train might have to drive away, or cancel trains. So in this case, if we have this, in this example, platform 3A and B are blocked, we basically compute a new platform occupation diagram like this, where now the blue trains are shifted to different platform tracks. And you see actually that we still are able to run all the trains. So if you can do this really quickly, if there's some kind of alarm that platform track is blocked, and you quickly compute, okay, come up with a new feasible schedule, you can still have all the trains coming in the station and actually do not have a disruption. You avoid a disruption if you are able to reroute all the trains. Of course, the problems could be more difficult. Like here, if there's 4 tracks not available, again, you can try to fit all the trains on the other tracks. In this case, it's still possible. The quality might be reduced a bit. There's now 43 buffer time rather than 1 minute and a half before. But still, everything is doable, and you can still keep the trains running, and therefore avoid disruptions. So that was a little bit quickly the railway traffic management. The third pillar is the automatic train operation. I think most of you know this picture. There's several grades of automation, where grade of automation 1 is basically only the train supervision, automatic train supervision. And from grade of automation 2 onwards, the trains automatically run from stop to stop. And for that, you need a train trajectory generated and given to the trains. So this gives an interaction between the traffic management, the ATO, and the railway signaling, which is shown in this picture. The orange blocks are the safety-related systems that all the railway systems have, the station interlocking, the automatic train protection, trackside and onboard, and the track clear detection. And the blue ones are more the operational control systems, starting from a traffic management system that gives targets to the automatic train operation trackside, and that divides them to the different trains on the ATO onboards, and they control the trains. And there's feedback loops, so basically the trains should be able to control themselves with small deviations. If the trains go a little bit out of the bandwidths that are given to them, the ATO trackside should check if there's possibilities to reallocate a little bit the buffers to the different trains. And if there's actually conflicts, then the traffic management system has to come up with new solutions. So in this way, there's an interaction between the traffic management and the ATO to keep all the trains conflict-free running. So as an example, this is an energy-efficient speed profile for a punctual train as it's scheduled over kind of 8 stops between on some corridor. In red, you see the static speed restrictions that should be respected, and the black lines are the actual speed profile that is scheduled. Now, if there's a 3.5 minute departure delay, basically there's less supplement available on this corridor. So what you can do to reduce the delay is run as fast as possible until your delay is over. Well, that's not energy efficient. What you can also do is say, okay, at the end of the corridor, I want to be on time. So I check how much supplement I have over the entire corridor, subtract the delay, that gives you still some supplements, and then you compute again the energy efficient speed profile, as is given now at the bottom plot. That gives much less energy loss. Still, you have coasting phases at all the, also at the earlier stages of the trip. Now, this should be combined with the advanced railway signaling. So just as a reminder, what kind of signaling systems we have. Usually we have conventional fixed block signaling where there's some kind of yellow signal indicating that the speed should, or that the train should reduce its speed because the next signal is red. So it usually reduces its speed at the signal, runs with a restricted speed until a stop. With radio-based signaling, a train actually has its own braking curve computed on the train, and there's a radio communication with the trackside that tells how far the train can run, and this actually gives an improvement in capacity to be closer to the leading train. It could be even better with moving block signaling. In this case, we don't have any trackside train detection segments anymore, but the trackside signaling systems know where the rear of the leading train is, and therefore the movement authorities can be given until just after this, the train running before. It could be even more optimistic using virtual coupling where the trains actually communicate with each other, and they can Also take into account that the train in front, it does not suddenly stop. So you can assume that if this train is braking, then you just brake along with them. So if you coordinate those trains, and for that you need train-to-train communication, you actually have a much more, the relative braking distances like you actually have with cars on motorways, for instance. Well, for this virtual coupling, which is really futuristic in a sense, you need a different kind of communication, train-to-train communication between running trains and train-to-infrastructure between the convoys of trains that are coupled in this virtual sense. Also, for a control point of view, you need to coordinate the braking of each of these trains within such a virtual coupled train set. So that if one of those trains starts braking, all the other trains brake along with it. And by doing so, you really have very short braking distances. Then the challenge is to have the trains coupled in a virtual sense during the track and also during, for instance, varying slopes along the corridor. So that this actually has a lot of challenges to overcome, like cooperative train control, to couple and decouple, and the stability of these platoons. So this is more for the future. Now, if we consider all these four together, we get the digital automated train operation concept, as is being researched in Europe's rail program in Europe. So if you look at the normal automatic train operation functions, it's about automatic driving, automated stopping, automated turning, and automated shunting, which are all about individual trains. Especially the latter is very interesting. If you can automatically turn a train without a driver needed, or even drive away the train on the shunting track, you avoid that the driver has to walk back all the way to where it's convenient to be. If that can be automated, also the drivers would be really happy. But there's more functions that you need when you consider multiple trains. So one is for conflict-free driving, it's not really useful to focus on one train. You need to specify conflict-free train paths to these trains. So that is this interaction with the traffic management system comes in. For cooperative train control, you need actually, so that means that the trains can communicate with each other and they can inform each other that they're braking or accelerating, and that can be used to really optimize the flow of the successive trains. And you can also do that in merging and crossing. So that would be more advanced control, not really about traffic management, but on the train level, the train interconnection level. And finally, you have the platooning with virtual coupling, where you have the trains really running after each other with this relative braking distance, where you really need this cooperative control. And this is about multiple trains. So this kind of ATO, which might be more properly called cooperative train operation, is still something to be developed. So then we have this concept of the digital automated train operation, or DATO, which is basically a combination of ATO, of single trains, the traffic management systems, advanced train signaling systems, and also the automated traffic control systems. And together, they are the future of the automated railways. So if you look at the pictures, the rail traffic planning should be able to come up with realizable conflict-free scheduled train path. That's given to the traffic management systems, and they have to be able to keep them up to date, conflict-free. And those conflict-free train paths in real time are basically sent both to the traffic control systems, who set the train routes, and therefore the movement authorities to the traffic control systems, the signaling systems, and also give these routes to the automatic train operation track sites, so that also the trajectories given to the trains is consistent with the route setting on the infrastructure. And there's some interaction with the signaling on board and the automatic train operation on board. In Europe's rail project, which started last December, I'm responsible as a work package leader for linking the traffic management to this automatic train operation. So I want to show you a little bit what kind of challenges there are, and that need also standardization to be able to do this. So in the middle you see we start with planning that's connected to the traffic management system by providing some kind of timetable, a good timetable. The traffic management is connected to the ATO trackside and the traffic control, and it gives a real-time traffic plan, which is basically a conflict-free traffic plan saying which track sections should be occupied at certain windows. On the train level, the ATO trackside then divides so-called train path envelopes, certain train path over time to the different trains, such that the trains, if they stick to these envelopes, will run conflict-free. And that then the trains can compute optimal train trajectories that are energy efficient and give the traction and brake commands to the trains. The trains on board can report the status back to the trackside, and the trackside can report status to the traffic management systems, and they can then keep on monitoring all the systems. Now, just to give you an idea about the challenges when you have these kind of systems, I use this graph to show you all the interactions. So first, what timetable will improve automatic train operation? This might be different than the timetables we are designing now. And what should be in the traffic management system? There's all kinds of modules that you can think of, like conflict detection, conflict resolution, monitoring, all kinds of things. What should be in there? What is part of traffic management? What is part of traffic control also? So how to optimize then this real-time traffic plan so that the ATO trains can run as optimal as possible? What details should be in these real-time traffic plans? How to optimize then the train path envelope that you give to all the trains? You can, the ATO trackside may choose to give a little bit more buffer to one train than another, to adjacent trains if that for some reason might be interesting, and it could also be dynamic. So if one train is getting a little bit disturbed, you can give it more buffer. That can be done at the ATO level. You don't need to involve the traffic management system for that. So what flexibility then do you want in these train trajectories? What feedback loop do you want from the ATO on board back to the trackside to improve performance? And also back to the traffic management system to indicate that we are heading towards some kind of conflicts that you want to resolve. Then it's not fully automated. There will always be people involved. So the next question is, how will the human roles change? Both on board maybe, but also in the traffic management systems, in the traffic control systems, especially also considering disturbances and disruptions that may occur. How will then also the people be in the loop and be quickly responding? Also, you can think of, you have some traffic management area, but is this the same as the automatic train operation trackside area? You could imagine that for traffic management, it's good to have a big station area with surrounding stations, but for ATO, it might be more appropriate to have corridors where trains running after each other. So how does this interaction of the decentralization of TMS and ATO work? Then, if we develop and think about this, develop some interesting concepts, is this already anticipated in the existing standards, or do we need a change request to these standards? How to simulate then this traffic management system and ATO interactions, and also under disturbances and disruptions. And how to simulate then the human in the loop also to deal with these automated systems. So this gives an overview of all kinds of still that We didn't have solved everything yet. There's a lot of things to be researched and to thought about to really optimize these kind of systems. So takeaway messages. First, a digital automated train operation is a combination of automatic train operation, traffic management, radio-based signaling, and automatic traffic control. And that's the future of the railway, automated railways. And if you look carefully, then the ETCS, or the signaling, facilitates safe, closer following. And the ATO achieves predictable energy-efficient driving within a small bandwidth around the scheduled train path. And therefore, they realize actually that short headways are possible if conflict-free. And the real traffic planning and management, they actually provide this optimal this optimal coordination to have this conflict-free path. And to do all this, you need operation research, or mathematical optimization, and train trajectory optimization, which is optimal control, to involve in all these areas of timetabling, traffic management, train operation, and also the signaling, if you, for instance, consider a virtual coupling. Well, I started saying that I'm the president of the International Association of Railway Operation Research. So here I also show the website, the iror.org. You can have a look more there. We just had the Rail Belgrado conference this year. And in 2 years, there will be the next conference where all these kinds of concepts are being communicated, disseminated, and discussed on these conferences. So have a look at the conference. If you are interested in becoming a member of this association, you can find a form on this website. So this is some references that back up my story. They can all be found on our website that you can see above. Thank you.
Thank you very much, Professor Rob, for the presentation and messages, which is very important. Let's move on to the next presenter.
Yeah, and next we are privileged to have him with us, Mr.Toby Tibigans, East Asia Cluster Managing Director from Alstom Thailand, who will be speaking on leading the way to greener and smarter mobility. Please join me welcoming Mr. Toby on the stage.
Good afternoon, ladies and gentlemen. I'm Toby Tiberghien, Managing Director East Asia for Alstom. I'm delighted to be here today to share with you the experience of Alstom in Thailand and also to show how we're driving a smart and sustainable solution, mobility solution in Thailand and in the rest of the world. And thanks again for the invitation here. I think these 2 days are a fantastic opportunity to bring the academics, the public and the private sectors, to bring them together and to share experience and how to develop the railway know-how here within Thailand. So Alstom, we have a long journey in Alstom in regards of greener and smarter mobility. We have been many times pioneer in the different solution of the network. And we work closely with our stakeholders to make the rail transport more intuitive. So I just wanted first to share with you what is Alstom in Thailand. In fact, Alstom have a rich history here already in Thailand with a presence for more than 40 years ago. We have been playing and delivering solutions, starting with locomotive to SRT in the 1975s and other projects later on. But also, very early, we believed in Thailand, I will say, ability to develop expertise, and we set up our engineering hub, first a signaling engineer hub, here in Asia, in Thailand, for more than 25 years. We have today in Alstom more than 970 employees, so we will certainly crush 1,000 before the end of the year. And you can see that we bring a lot of different nationalities together, more than 24 nationalities together, to bring the experience from the different parts of the world. But we also are here to develop the local competencies, and we are more than 88% of Thai employees here in our engineering center and offices in Bangkok. Second point is, it's not only an engineering center on signaling, but we are combining all the expertise that we need in the railway. So we have signaling and we have system turnkey abilities, know-how here in Bangkok. And since a couple of years, we are now having already more than 1 million hours spent every year on engineering for Thailand and for worldwide. Alstom Bangkok, Alstom Thailand, is involved in more than 100 projects worldwide. So just to give you another side of the expertise that we have, as I said, we are trying to cover the full expertise in terms of railway subject here in our site in Thailand. We have expertise in electromechanical subsystem, in signaling. We have expertise in integration systems, expertise in product development. We are spending roughly 5 million euros of R&D every year here in our engineering of centers in Thailand. And we have expertise in commissioning and service on the different fleet. On top of that, it's not only an engineering center. We have decided, because we consider that Thailand has also a strategic position within the Asia area and East Asia area. Our headquarter office are here in Thailand, and all the central functions, so I would say the finance, HR, legal, commercials are here. So we are delivering projects for Thailand, projects for worldwide, answering also some maintenance activities, developing service center here, and providing regional engineering. So for us, Thailand, Alstom in Thailand is already a long journey. As I mentioned at the beginning, we start in the 1970s with delivery of the locomotive. Then a few projects with SRT in the end of the 90s, beginning of 2000. And then our, I would say, urban experience started with the different projects on Green Line, Blue Line, Purple Line, and on the other different lines that we have. Up to now, recently, as you can see in July, we have supported the revenue service of monorail Yellow Line here in Thailand. Just to give you some iconic projects, and where you can see here contributing from the engineering side that we have in Bangkok. We are highly contributing and involved in the different projects for Thailand and overseas. So here again, BTS SkyTrain Green Line, the Pink and Yellow Line, the Gold Line, the Purple Line, and also you can see projects in Malaysia, India, Australia, or even one iconic one which are in Mexico with Train Maya. And we are continuing to support new projects in Philippines, in the different places of the world. So I wanted to say that we early believe that we have here the ecosystem from the different universities, the different willingness of the government, of RTRDA, and the other associations on railway and research development to develop the expertise and develop the know-how of railway here in Thailand. And I think this is the best way, putting in place engineering center with different testing labs that some of you will have the opportunity to visit on 2 days later. to have a partnership and developing new solutions, having R&D projects together. Now, let me present you also two other aspects which is a concern and could be a topic for Thailand. Is first the high-speed solution, and later on solution regarding to green mobility. So first, regarding to high-speed solution. So Alstom, along with our partners, we start, I would say, in the 1970s with the SNCF in France, and then globally on the world, have been partnering to deliver more than today 2,900 high-speed trains over 25 countries. We have bring our expertise in high-speed train design and development to different countries. I think you could have seen some iconic transfer and iconic transfer of knowledge to Korea, to China, to other countries in the world related to our high-speed technology. So we have more than 40 years experience in terms of designing and manufacturing high-speed train, and we are always looking how to improve the solutions. So we have developed around the years different solutions, looking at how to improve reduce the traveling time, and this is thanks, for example, to the tickling solutions that we have developed in Alstom on the high-speed rail, or how to optimize the energy consumptions. More recently, so with our new developed Avelia Horizon solution, we have reached another 20% less energy consumptions, which by improving the aerodynamics and the traction efficiency. Again, just to make the link to also the third part of the presentation, high-speed rail is the most sustainable way versus air and road to connect cities together. We have been, I think, repeating this since the beginning of the day with Dr. Catherine Luger, with the other participants after that, that railway solution is effectively emitting much more or less. We are talking about 10 times less CO2 emission per kilometer, lower overall energy consumptions, and lower overall land occupations. Okay. All right. So last part related to, I will say, greener mobility is on the fuel solutions. So let me introduce the different green solutions that we in Alstom believe in. So just to, again, repeat a little bit where railway stands. As you can see, the train is one of the least emitting mode of transport. Okay. If you compare the rails in terms of gas emissions, we are 19th, where if you look the bus 63, the plane 123, and the car 148. So Alstom has committed to directly contribute to the sustainable development goals and have the plan to reach by 2050 the net zero emission. So it is key, and we look at that in all our operation. We look, the emission of CO2, there is different level of aspect or different scope, what we call scope 1 and 2, which is more linked to our operations. Scope 3, which are more linked to our overall supply chain, including suppliers in one side, customers the other side. So we have already ambitious target by 2025 to reduce by 25% our energy consumptions and to be 100% in terms of eco-design of our solutions. And by 2030, we will continue our CO2 reduction, and by 2050, we will reach net zero. So in terms of solutions, there is two ways in terms to reach this, I would say, net zero emissions when we have non-electrified lines. Okay? We have solution for new line or new assets, okay? And which is, for example, battery solution on the right, BMU, or hydrogen solutions with fuel cells. And we have also solutions when the line existing, assets are existing on how to having B modes or how to help to support retractioning. And that's why we have some B mode solutions, diesel, EMU, hybrids, diesel plus energy solutions together. On this aspect, to reach the green targets that we have on the different countries, we need to have a panel of solutions which should be applicable to each type of scenario. So, hydrogen solutions. Alstom is, I would say, the first one to have implemented in revenue service a hydrogen train, intercity hydrogen train in Germany. It's running since September 2022, especially developing in Germany and in Italy first. We have a Coradia I-Linked in Germany and Coradia Stream also in Italy. And it's just the beginning of the journey on hydrogen. Okay? The hydrogen, of course, hydrogen train need an infrastructure. And this is where things around need to be discussed with the different authorities, need to have planned in advance because we need to have the ecosystem in place. And of course, it's worthwhile when from the beginning, the hydrogen that we are using, we are pushing to green hydrogen production. So hydrogen are today's common to be used in some trucks, in some cars, etc. Now it's become on the train. It's just the beginning. And we think it is a promising area to further develop. Hydrogen has several advantages. Of course, it's a zero emissions. Okay. It's a high reliable and high availability. It's allowed to very long distance. We are able to run 1,000 kilometers without recharging the trains. It has a great also improvement in terms of reduced noise, okay? And other, I would say, helping the development of the ecosystem. The other type of solution are battery solution. So Alstom battery solution is another compiling solution for partially non-electrified line. Okay. So this slide will give you some quick glance of how the solution is increasingly adopted in several countries around the world. So same, we have started with, I will say, origin of Alstom. And then we start with the south of France. Then we have also in Germany, that now we also have in England, in different countries. And we have battery solution in different range of products. So starting with Citadis, which is a tramway on batteries, which is running in Nice in the south of France, or in some suburban intercity solution with Extrapolis or Coradia that you have here in the different cities that we can have in Germany and we also have in Netherlands. Okay. So with the ability on the BMU allow usually travel up to 100 kilometers on battery power alone. So it's an ideal solution, an ideal, I will say, a cost-effective solution for short distance journey, or as we said, for mixed operations where we have a non-electrified line or we have a portion of the line electrified and portion of the line non-electrified. So for instance, for example, we say usually you have 70% electrified, 30% non-electrified, you can run on batteries and recharging the batteries when you are on the electrified portion. it's allowed to have a better consumption of the energy around the line. Okay. This solution is, of course, easily applicable for new train, but it is also more and more obvious when we have already existing fleets and we would like to upgrade the fleet to a greener solutions. In that case, we have solution to retraction and moving from a pure diesel solution to a mixed solution diesel battery. Okay. So in short, as I mentioned, battery solution is good for 100 kilometers line. It's, of course, the TCO is lower, so the overall cost is lower than a pure conventional design solutions. It is a green solution as it's reducing the CO2 and also the other gas. It also have benefits in terms of noise, benefits in terms of operability, and in terms of passenger comfort. Okay. So, globally speaking, I would like to finish this presentation to once again saying that so far Alstom has been very glad to be here in Alstom for more than 40 years. We invest here in Thailand in our engineering competencies, developing the local expertise. We are glad also to say that every year we are having roughly 20 to 30 new young graduates from top 6 universities in Thailand joining our team. And we are also glad to export, I will say, Thailand expertise around the world. Now we are trying to export our Thai colleagues in projects or in other areas that we have in Australia, in Malaysia, even in US or in Europe. And we have been confident that this partnership between the different institutions, again, between private and public, is very important to develop the ecosystem and to continue towards this development of competencies here locally. So, thanks again, and welcome to discuss with all of you for further partnership. Thank you.
Thank you so much, Mr. Toby, cheering us. For your sharing your knowledge from Alstom Thailand. I think we all learning new things from you. Thank you so much. We are appreciate for that.
Now, our final speaker before the break, another break, is Professor Jing Gu King Jing, the Professor of Highway and Railway Engineering Department from Beijing Jiaotong University, China, and he will be talking about the smart railway monitoring and evaluation technology.
Ladies and gentlemen, I'm Jing from Beijing, and it is my honor and a pleasure to share the state-of-art industry and the research carried out in the world, not only in China. The topic of today, my presentation, is railway infrastructure smart evaluation, mostly by robots. Okay, this is the outline of my presentation. First overview, and then problems and challenges, and then the prospect of research and application in China. China is a developing country with a huge network. For example, for the past 10 years, we increased with another 50,000 kilometers of railway, and almost 10,000 kilometers of metro system. It is a huge market as well as lots of industry oriented. This is network of development history of China. And the operation speed, you can see, like 50 years ago, we share the same speed level, normally less than 80 kilometers per hour. It's true, I would like to emphasize that from 1979 to 2007, it took us 10 years for 6 rounds of speed up, increase our speed level to 200 and 250 km per hour. In fact, by 2007, we have more than 8,000 kilometers of railway after speed up can run at a speed of more than 200 km per hour. At that time, we become the biggest network in high-speed railway. At that time, not only for speed up, one or two railway newly built, the speed is just 200 and designing speed 250 km per hour. And 2008, our first high-speed railway designing and operation speed is 350 km per hour. Now, Beijing-Shanghai high-speed railway, the speed is 350 km per hour. For example, like 20 years ago, from Beijing to Shanghai, it took 24 hours. And about before 2008, from Beijing to Shanghai, it took 10 hours. But now it takes less than 5 hours. Normally, the high speed is 4 hours and a half. Now we are testing. We spent 3 years testing the high speed 400 km per hour. This is speed. For our inspection technology, normally we have two types. One is static geometry inspection based on like gauge, ruler, trolley, absolute and relative method for track quality. This is static. And we also developed dynamic track geometry. We import the technology from other countries and develop our own system, generation by generation. Increase the speed, increase the system, increase the the software for analysis. And this is the high-speed trains in evaluation, the track quality. For example, this one, we have more than 13 high-speed inspection trains with a speed of operation 350 km per hour. This is fleet is run by China Railway Academy of Science, responsible for all the China 50,000 kilometers for high-speed railway inspection, each month with twice of inspection. And we also have other low-level track recording vehicles attached to run by the railway companies, 18 railway companies. And for our track inspection, in the past, we mostly depend on labor, manual, and start from like 15 years ago, we develop computer-aided, like big data, like a sensor, like manager analysis. Nowadays, we most of our result analysis and censored by computer science. We call it like a smart management system. This is our maintenance management system, like the standards for railway maintenance, periodically maintenance and centralized maintenance, and from before COVID, we decided to depend on predictive, mainly preventive maintenance, but mostly we call it like centralized maintenance. This is our maintenance management system. Now we talk about the problems and challenges for the China Railway track maintenance and evaluation. The problem is laboring, the first one. In the past, for example, like 5 years ago, 4 years ago, every year China have more than 20 million newborns. But last year we only have 9 million. It is totally sharp downsize of reduction of labor. This is the first challenge for us. This brings us some economic issues in China. And also the second one is high cost labor. Each labor in China, for example, about at least 1,000 US dollars or euros monthly, the salary. And we all know that the track quality inspection, we call it 4DS. Difficulty, dangerous, dirty, and boring, and dull. No new young people like to take the railway inspection working because it's subject to human experience, time consuming, and mostly working in window time, which means very late at night. Young people even prefer to take work as a deliveryman, a mailman, take the scalper, run across the city, and the salary still paid very well. So this is the problem for Chinese railway maintenance. Another thing, in fact, in China, we have more than 800,000 railway workers for railway maintenance. But in the past 10 years, with increase our network, but our railway employees, no increasement, which means that we have less employees per kilometer of network. Okay, I think this same thing will happen in Thailand maybe 10 years later. This is our challenge. We want to use less labor, reduced cost, and in nowadays, China, we develop robots. Robots, for example, if you travel in China, the restaurant, the hotel, there will be lots of robots for serving the calls, delivery reception, and even for, guard system. It's very popular during the COVID, and it has become a very popular industry for China. So lots of young and startup companies working on railway robots, for example. Another solution is UAV for inspection. But there are problems in China. For example, the first thing is rights for flight. Because in China, we have a very strict space rights control system. For example, in Beijing zone, all year round, there is no allowance for UAV operation. The second one is pilot qualification. But now we have the laws for these regulations. But for the UAV, for railway, they have many good advantages in, for example, the safety inspection. Everybody knows that lost railway went to operation, put into operation, because there is no fencing, there is no railway regulations. Local people stole away the parts, fasteners, and result in big problems for the railway safety. Now we employ UAV for monitoring, for parallel, for safety. Because in China we have many railway overseas products. For example, the same thing happens in Serbia. There is no regulations, there is no fencing. So there are lots of problems like violate, steal, and the local animals run onto the track. But now we are using UAV for patrol, for management. Another thing is one for my research product, we use UAV for desert land, sandy track. Before and after sandstorms, we use UAV for the sand drift accumulation, distribution. Then we can make a decision for resources for maintenance. Okay. Now we talk about railway robots, and this is one from review paper I wrote it with my team. This is like a challenge perspective of railway inspections. There are many railway robots companies in the world. For example, the first one is Italian. They provide this. The first one. The second one is EU research product. It looks ugly. The third one is Railport from American companies. This is automatically can run on the track. Another thing I want to mention that on the BKK airport, Bangkok airport, I saw automation robot for cleaning. This is my first time to see it in Thailand. I think why not put it into railway and highway like maintenance. This is China's, we have like 6 companies developed in China focused on railway robot. The first one, Shenhao, is one of my collaborators and use railway robot for track quality, fastener, as well as the profile of track. The second one is GD inspection robot companies. And this is what we did. We did the test in window time for the tracker, for the fastener missing, profile. Another thing I want to mention that the robot and in the market is less than $2,000. And this is one of the trial projects carried out in Netherlands. It's like carry on to reduce the trouble and labor of the railway workers. I think in the future with technology of battery and we will have more robot pair with inspection engineers, reduce the trouble and the loneliness. Okay, this is the track fastener robot developed in China with cars and my team. The first one, the left side is, okay, left side robot or fastener, it can install and deinstall the robots, the fastener, to remove the trouble of the workers. So this side is bigger one for all the fastener installation and deinstallation cleaning. A very big one, but we have trouble in putting it into operation because China Railway Department has a very strict standard for this vehicle put into operation on the track. We have standard as strict as a vehicle of rolling stocks. So it is still put into, how to say, the storage. And we also have the robots for the undercar inspection. We have 3 robots company in China. And we have this robot used in China railway companies as well as metro companies. We export to Hong Kong and Singapore metro system. It can reduce 80% of the engineers for inspection. And with cameras and before and after for analysis, very quick, 15 minutes, automatically run. And this is one for the roof inspection. We also have the robot for OCS, overhead catenary system inspection, especially for the metro system. There are also railway robot company developed in China and in the world for the railway bridge inspection. This is like our categorization, and this is also some examples from France and other countries for different type of application. And there are lots of bridges in China across the river. So in the past, we use divemen, normally retired from the military service, and dive into the river to detect the pirates. But now there are many railway robots company develop robots to detect the pirate, like the corrosion, damage, and use data analysis, computer science to analyze, to provide a report. For example, for our Changjiang River, for our Yellow River, the big, and even for some bridges across the sea. This is maybe this one. Okay, there are these are products from like Hamburg and EU product, but we also have our own system. But I think our system looks so ugly, so I don't present our photos here. But how to say, the Hamburg and EU product design very looks handsome and smart. So we use this. Each of this machine is about 1 million, more than 1 million RMB. But it can reduce the labor and work of railway workers. We have the system with, for example, GPR, with laser, camera, for all kinds of non-contact evaluation of the tunneling, lining, as well as like a profile, falling rocks. This is the one interesting from Japan. You know, Japan and Korea, they have like 20 years advanced than China, which means they have more senior citizenship than China. So with the aim to reduce the trouble and laboring, they use VR plus like an operation robot to do some overhead OCS maintenance work. Interesting. And next part is part of my team research and perspective for the future. Okay. In fact, for the past 20 years, I have been working on ballast track, like ballast, sleeper. You know, almost China huge scale of railway construction is coming to an end. Most professors shift from structure dynamics to evaluation. So this is my global vision about the future railroad inspection. And let's first is smart sleepers and INSA, as well as GPR and robot. This is product from Netherlands, RILA. In fact, China and France, many countries develop a similar on-board inspection system. Sensors, we have our own system. This is quite efficient and less expensive. I think this system could be valuable for most developing countries of track quality inspection. This is GPR, and I noticed that Thailand has one high rail company developing rail infrastructure inspection. We developed GPR for track maintenance. During the COVID, we have tested more than 30,000 kilometers of ballast track in China. And this is our system inspection and also validation. We set up a track of 30 meters for different ballast quality for validation our GPR system. This is my publication during the past 4 years. This is a manual, but we normally during the operation, we just install it under the car body. It can run at a speed of 160 kilometers per hour and collect the data, and then my team make an analysis and then make a report to the railway company for maintenance, for tamping, for cleaning. It can detect like the moisture, the fall index, as well as the thickness of ballast bed. This is my research. This is relay system developed. One of my former students worked for this company. So and other countries like Germany, as well as America, they also have similar product and service. And we also have our own system on board, sensors to detect the track quality profile. But this one is special. It's in front of the car body. In China, it is forbidden to install it in front of the car body. Most of our onboard system is in the car or under the car body, not in front of the car. Now we talk about smart sleepers. In the past, the sleeper is just one important part of the track, keep the geometry and distribute the force to the substructures. But one idea occurs to me, why not make it smart? Which means to install sensors to record the dynamic acceleration and to, recover the energy from solar. So inspired by several companies' products, we published a review paper, 2 review papers. And one of my former PhD working with CNTS, we published several papers, make the sleeper sensitive to deformation. This is the carbon nano sleeper, which when we add the carbon nanotube to the concrete, the concrete sleeper deformation will result in electricity resonance change. And then we collect signals weekly, monthly, so it can become like a smart sensor or recorder. If we put 10 or 20 smart sleepers along the track, it becomes like a structural health monitoring system, cheaper and reliable. This is one of our ideas. And since we did the test, like calibrations from the material to the small beam and then to a real sleeper, and dynamic as well as static loading to test like the resistance, in fact, the signal of electricity. It works very well, and this is one of our ideas. Next one is piezoelectronic sleepers. And green railway as well as digital railway is always the trend of the railway development. So why not to collect the electricity due to the cyclic loading of the passing train? So one of my master students working on this to buy the sensors, installation during the concrete sleeper fabrication. But this test does not work very well because of the pre-stretched concrete sleepers. There are too many steel bars. Next step, we will use composite sleepers made of plastic or rubber. So there are no confining or disturb steel bars. Next, we talk about smart ballast. And smart ballast, in fact, this idea was initiated 10 years ago by UIUC and put sensors into the ballast and 3D printing, things like that, to make the ballast become smart, and we can get the response of dynamic acceleration, displacement. One of my research is use machine learning to predict the ballast breakage. We validate 5,000 ballast particles under the crushing machine, and to test then we can predict the ballast breakage due to the loads. This is one of our papers. Next, by conclusion, and I think smart robot as well as smart track could be used for the future railway track quality evaluation as well as health monitoring. Artificial intelligence technology to improve the level of intelligence. My team, 1/3 of my students working on machine learning, computer science, with background of software civil engineering, but from the master degree, 3 years, totally working on computer science, like machine learning, AI, together with automation engineers, electricians, sensors. And in the future, in my opinion, it will become, a system from the substructure, the track, as well as the train, work even from the aerial, like satellite, like a link from Moscow, working together to make all time, all space to monitoring the track or the safety of train operation. Okay, thank you, and thank you, that's all.
We are now entering Keynote Section 3, Let's begin with our first keynote speaker, Steven Strong, CTO of Rail Industry, Aviation and Rail BU, Huawei Enterprise Business Group, who will be discussing on the topic New ICT to Facilitate Future Smart Rail. So everyone, please welcome Steven Strong to the stage.
So, okay, good afternoon, so ladies and gentlemen. So I'm Steven Xiong from Huawei. And firstly, let me thank to the organizer of this conference, and thanks to the invitation of Railway Research, Railway Technology Research and Development Agency and the Ministry of Transportation. So it's very glad to see here so many friends and discuss together for railway industry in Thailand. So Huawei has involved into this industry for almost 28 years, and we have committed to digitalization with new technology like cloud, big data, AI, and so on, that you have just discussed a lot of things regarding this point. And we have developed a lot of innovative solutions for future smart railway. And we have got some, I think, successful experience in this domain. So here I would like to share how new ICT to facilitate the future smart rail. So after industrial era, electric era, and information era, so we think the rail industry is coming into smart era. So compared with previous eras, so we think in smart rail, the big difference is the endless data is becoming more and more valuable. So with the data sharing and the data development, so that means in future smart railway, so we will deploy a lot of smart applications. And finally, I think for the rail industry, should move forward to the mass with its mobility as a service. So regarding the smart railway, so what's the concept we proposed for this industry is we think in the future, if the smart rail is totally, I think, new concept for future rail industry. So we think the ICT architecture should be new and totally different with before. So we propose its full service architecture based on a diversified connectivity and unified digital platform. What's the meaning in this architecture is we just I heard a lot of experience and Professor Jin talk about a lot of smart applications. So I think based on this kind of smart application, that means we should provide more and more connectivity from trackside station and provide high bandwidth connectivity to collect data from trackside station, even the train to control center. So this means, so in this, I think architecture is at the bottom. The first thing is we should focus on the connectivity, I think with new technologies. So from Huawei side, it's what we proposed for rail industry is three kind of network with new technology. First one is wireless communication between train and ground. What we proposed for metro is we propose LTE-M. It's LTE for metro. This is the first one. So if our customer has a frequency band, so this is the best one we guess is, right? So the second one is we provide Wi-Fi and so on. And also we can provide some, I think, high bandwidth based on IP and optical transmission. So this is focus on the connectivity part at the bottom of this architecture. In the middle level is what we propose is we say it's digital platform. So actually, so on this platform, it's what kind of new technology provided from Huawei side is based on cloud, big data, and some AI technology. So we should, I think, transform the traditional architecture in this part. So you know, in the traditional architecture, each application should deploy different server, different storage, and network, and so on. But in the future, if we consider the future smart railway, and smart metro, the platform will be totally different. So we should consider the new technology, cloud, AI, and big data to do some details regarding the application used in real industry. So this one we will discuss some details after this slide. I think in the upper layer, of course, there are a lot of applications. So we have deployed, currently we have deployed in the metro and the railway, AFC, ticketing, and CCTV, blah, blah, and so on. A lot of subsystem is deployed for operation and the maintenance part. In the future, I think for this part, totally different with current situation, we should use some cloud-native technology to reintegrate all the application. So what it means is we should maybe recode some application. So based on service, we should put all this kind of application into container, virtualization machine, and so on. It's kind of new technology. So what's the benefits bring to our real industries in the future? So currently, for example, if your some application is in one station, is failed, break down, okay, shut down, okay? So you should arrange some works to the station and replace the hardware by spares and so on. But in the future, so all the infrastructure will be managed by code. So you can manage, replace, repair from network management system, and to do a lot of things for repair and maintenance and so on. And the very key important one thing is here is we also proposed with this IOC. IOC means Intelligent Operation Center. So we consolidate all the data from different applications in metro and railway, and we put them into our big data lake or big database. And we centralize all this data may be based on different themes and to support future smart application regarding operation and maintenance and so on. So you can image in future. So the current almost all the data and the situation from metro and railway operation and maintenance, the situation can be seen in the big screen in your control center, and it can be managed and monitored from your computer and the smartphone and so on, not only by your management and employee, but also I think it's so all this kind of with its data and the situation can be seen by I think everyone defined according to the right defined in your IT system and so on. It's decided by your policy of your company for operation and maintenance. So we understand in the future, the totally, I think if we transform the digital transformation, we should go through the 3 steps. The first step is reshape connectivity. So this is very important, is foundation. The second one is we can reconstruct a platform. We just talk about cloud, big data, and so on. So this kind of things. So I think for the third step is enable intelligence. So once we connectivity and the platform is ready and the big data lake is ready, so we can do more things regarding the applications. So in this part, we will cooperate with our partners, especially with our local partners to provide smart application for our customers. Actually, so outside of this conference room, so we have a booth, and we have presented a lot of detailed application for almost all the components we just talk about. I just talk about in this slide. So if you're interested for this part for some details, you can discuss outside with our colleagues for some details. So in this workshop, I only highlight some solutions we want to discuss with your side. The first thing, of course, is connectivity. So it's the foundation I just mentioned. So actually, telecom connectivity is a very important competence of Huawei. So Huawei fully connected real systems can provide connections not only, I think, in the station, depot, and the remote terminal to control center, but we also can provide connectivity. So maybe from the operation center of the line, and collect all this kind of data from different operation center to maybe we see it's city, maybe operation center and so on. It's kind of high-level operation center and so on. So based on a different technology, so from track side to station, so we just talk about it. So we can provide LTE for railway. So what we proposed is FMCS. So future railway mobile communication system defined by USA. And for the backbone, so most of, I think, the solution we proposed is based on IP and optical transmission network and so on. So I can discuss some details one by one. Firstly, I think we can see in optical network. So we see it's all optical network. That means in the future, we will replace all cable, I mean the copper cable, so defined by CAT and maybe some old technology and so on. Why we should firstly consider this kind of all optical network? Because safety is the first. So when more and more, I think, CCTV, HD camera deployed along the track side, the more and more new, I think, tech applications deployed in the real industry, for like signaling, we just some experts talk about signaling part, and FMCS I just mentioned this kind of new, I think, application. So this kind of, I think, new applications need a more reliable network to support. So from Huawei side, it's our all optical network. So you can see in the middle of this slide we have a 2 layers network proposed to the real industry. The first layer is we can deploy in the lines. In the lines, we have I think in one we see it's U1 fiber. We have two planes and so on. It's kind of technical to connect the station to the line operation center. The second layer is actually I think the advantage of this layer is we can provide high bandwidth to collect the huge data from the line operation center to the city operation center. You can see it's right. So what's the feature we provide for this new, I think, network is, I just mentioned, is one fiber, two we see the plant. So what's the meaning is we can use one fiber to transmit the old technology like SDH, like PCM, this kind of interface. Maybe sometimes it's provided by the old systems and so on. And we also can provide some, we see it's, I think it's one kind of new type we see is OSU. So it's new architecture for optical transmission part and can provide very, very high bandwidth and can interface almost all the interface provided for in the real industry and so on. So this is the first thing future we can provide from this network. The second one is, we just mentioned in the future, it's smart era. So that means in the control center, almost all the platform will deployed by a cloud platform, cloud technology and big data. So our all optical network can transmit data by one hop. So we see it's one hop to cloud. So because the cloud technology is very sensitive to the latency, data latency. If you want to transmit the data from trackside station to remote control center, so this kind of feature is very important. Next move forward is next one is we wanted to talk about train to ground communication. So actually, so we have two different scenarios. So one is for metro, another one is for railway. For railway part, I will discuss later. For metro, actually we also have a different solution. So totally this kind of solution can provide from Huawei, but depend on the free availability of the frequency band from local government. For metro part is we have two solutions. First one is LTM. LTM is based on private frequency band. Huawei has deployed this kind of solution in China market, metro market. Almost you can see in China metro market, almost all the new lines will be constructed based on LTM architecture. So we use China metro customer use one network to replace two Wi-Fi for signaling and one Tetra for voice communication and one more Wi-Fi for onboard service for the data communication between the train and the station and so on. So let's use one network, LTM network, to replace four. You see, it's we don't see it's an old network, but it's it's the older construction model. Yeah. So this is the one. But here I focus on Wi-Fi 6 because from Huawei side we also can provide a Wi-Fi 6 train to ground communication system. If local there is no private frequency band. So we have deployed this solution in lot of, I think, railway projects and the metro, actually in metro projects. So in our Wi-Fi 6 solution, we can provide 1.4 Gbps and 30 millisecond switch over time at the speed of 160 km/h. So it's perfect. So currently we have deployed this solution in Turkey, Istanbul Metro UUC line to transmit an onboard service. So 16 HD cameras and the PIDS, which is passenger information system from the onboard from train to stations. Okay, so this is the one. The second one also is regarding wireless communication between train to ground, but normally deploying this kind of solution for railway industry. I mean, for main line and the freight transportation part. I think FRMCS is a new standard defined by UIC. Actually, FRMCS means Future Railway Mobile Communication Systems. And in future, this standard, these systems will replace GSMR. GSMR is GSM for railway. And Huawei can provide end-to-end solution for FRMCS. And we have deployed this kind of solution outside of China, and we deploy one project in Mozambique, CFM. So we say this is the first LTE-based FRMCS in South Africa. So for Mozambique CFM, so for this customer is responsible to transportation for port and railway. So with more than 2,000 kilometer railway lines. So we have deployed the phase 1, phase 2, and is delivering for phase 3 and phase 4. In the future, we will cover the whole railway systems from, I think, Mozambique CFM. I think the benefits after our, I think, FRMCS solution deployed. So you can see the safety and the efficiency is improved from these systems. And you can check the transportation capability so doubled. So since after this solution deployed in our customers and so on. So after the connectivity we just explained, so we also should consider, then we should consider platform and the smart rail part. For platform, so for smart part, it's what we first thing we should, I think, propose is IOC, Intelligent Operation Center. So we may think the IOC is brain of digital twins in future smart rail, I mean for smart metro and smart railway. So in this solution, what we can propose is, what we can done is, I just mentioned, so almost all comprehensive situation, if you want to know, so you can get from this solution, from the big screen in control center, from the computer in your office, and from you can get all this kind of situation from your smartphone, based on rights defined by your systems. Okay, so you can access, what you can get this kind of situation. And also from our IOC, so we can provide the decision-making support. We also can support, urgent, I think, response in the future if you need. Yeah. We have deployed this kind of solution almost in a lot of, I think, metro project. I think a very important project for Huawei is Shenzhen Metro. So actually, we have done this platform. We have deployed firstly for 2 lines. It's Shenzhen Metro Line 6 and Line 10. And currently, we are transforming this kind of platform to cover more and more lines. And in future, we have get a frame contract from our customers. So we will transform all the lines in the future. So currently, we have defined more than 1,000 key indicators. So this is the first step. Is you should restruct the data and from different applications and put all this kind of data into our big data lake and so on. So a lot of works and development should be done firstly before smart application. I mean, in our cloud and digital platform. So this is what we have done for this solution part. I think if you consider, so IOC is very important. It's very interesting. It's right. But it's not enough. So IOC is only, I think, located in the operation center. But how to collect all the data from the trackside and from the station. So we need a new architecture network. What proposed from Huawei is we see one cloud. What's the meaning inside? It's we should consider the connectivity end-to-end. I mean, from the city operation center to the line operation center, to the station and the depot. You should consider all this kind of, in station we also have server for AFC, for ticketing, for CCTV and so on. So you should consider we can manage by cloud technology directly to this kind of, I think, infrastructure in stations. So for station, what we propose is in Huawei solution we see is DCS. Actually, we see it's a light cloud platform. So it's based on virtualization platform, technology, and so on. So in the line control center, of course, we should consider the cloud platform and big data and so on, this kind of new technology. So for city operation center, so I think, sure, of course, we should consider cloud platform also. We should consider redundant and active-to-active operation center, so on and so on. So this is, I think, the whole architecture we should change so in the future project and the layout. So let's zoom into to see so what's the detailed architecture in one station. So the station I just mentioned is you can see in the cloud on the upper of this slide. We see the DCS is night cloud platform, but it's not enough. We will replace one station connectivity with optic transmission. Yeah? So we integrated, we see it's PON and IP, new IP based on IPv6 or IPSR, new, I think, routing SRv6, so SRv6, new routing protocol and so on, to reconstruct the network in station. So to cover different situations. So also we should integrate it with Wi-Fi 6 to provide wireless communication for your office, for passengers, and so on. So it's different architecture. So compared with the older, I think, construction model. I think once we finish in the deployment of IOC with its platform and the connectivity part, so you can consider to do smart applications. So for smart applications from Huawei side, our target is to cooperate with our partners, so we can provide this kind of smart application which cover all life cycle, including construction, operation, and maintenance. So let me, I think, for example, for the operation and the maintenance part. So we have deployed one solution. So to analysis, so we deploy the camera to get a picture for the pantograph, and get a picture from the tower for the rear. So and the analysis the data and the analysis the information from the pictures. So this is one kind of predictive maintenance solution. So with some new technology, for example, train to ground for 5G or Wi-Fi 6, it's kind of new technology, and with AI, big data that we have deployed in a platform in our OCC control center and so on. So we have deployed some, I think, this kind of new applications from metro projects, from metro customers, for our metro customers and so on. And of course, we have some, I think, a lot of, I think, new smart applications for passenger, for operation, and so on. So I think in the future, we can, if you're interested for this part, we can discuss more details regarding this part. And one more solution I want to highlight here is we proposed this new solution in this year because the safety is most important for rail and metro operation. So we proposed the parameter detection solution for rail industry. So I think the technology behind it, we deploy the sensory fiber cable along the track side, and we can detect the intrusion with vibration detection and confirmed by the camera deployed along the track side from remote station and remote control center. So actually, this solution is different with ours. So we can provide full weather and provide long-distance deployment and provide full coverage and so on. And we can ensure, I think, the zero missing alarm and provide no false alarm and so on. It's kind of new features for our customer. Okay, so I just talk about a lot of things regarding the new architecture and new applications and so on. But I think all this kind of new texture and the new solution cannot be done by Huawei itself. And we hope we can cooperate with a lot of, I think, local partners to do this kind of things. So currently in the global market, Huawei is cooperating with more than 160 partners to do this kind of smart application, maybe smart solution to cover different areas in rail and in metro. For Huawei side, it's currently, so our solution is serving for more than 150,000 kilometer railway lines, and we also provide our solution for 300 metro lines in the global market. So, but we hope in the future that we can get more projects with our local partner to provide more, I think, solution for local customers. So, thanks very much. That's all from my presentation. Thanks for your time.
Thank you so much, Stephen Strong, for your sharing new innovations and technology on smart rails.
And our next speaker is Mr. Philip Schulsinger, Asia Regional Director, Business Line Transportation, Aegis Rail, Thailand. He will be talking about LRT, tramway system and operation. Please welcome Mr. Philip.
Good afternoon, everyone. So today, on behalf of Aegis, I would like to say first that I'm very honored to be present and have the opportunity to make this presentation about tramway that I believe is one of the future key components of secondary city like Chiang Mai, Phuket, or Khon Kaen, and that I would like again share our knowledge and experience from Europe. Before, maybe just for people who don't know necessarily Aegis, so some key figures about the group. So Aegis is a French consulting company. In 2022, we did a turnover of about 1.5 billion euro. So the particularity of Aegis is that we have two main activities. 80% roughly is about engineering, consulting and design. And 20% is about operating infrastructure assets. So you can see, for example, we are currently in a concessionaire for 20 road companies, expressways. We are also operating and maintaining 20 airports and also 21 urban parking contracts in Europe. So Aegis Group is about 18,000 engineers and people, staff. 75% consulting design and 25% for O&M. We are obviously a French company, but with majority of our activity being done outside of France, so we are very international. And you can see in terms of a breakdown of activities, so 20% is related to rail, so this is our major part for transport, then roads. Also, we have a business line related to building, urban planning, and architecture, which represent about 25% of the activity, and 20% other related, like for water, ports, maritime works. In terms of Aegis global offer, so we can service our customers and work with partners for the full, I would say, life cycle of any project related to transport infrastructure, urban, also development, and energy and industry. So from feasibility studies toward the full implementation of a project. And as I said earlier, also in terms of operation and maintenance, we provide also services. In terms of our local footprint in Asia Pacific, so we are present in Asia since 1955. And today, in fact, we are about 2,000 employees in the region. What is very important for us in relation to Thailand, Thailand is our transportation regional hub. We are present here for more than 30 years in Thailand. We have about 120 people, staff, working mainly in rail and civil infrastructure works. We have also a team developing MEP and also urban architecture activities. What is important to know, it's for Thailand, again, we are a regional hub, but also for the rail activities and the civil. We have, since last year, been more a world, I would say, support for Aegis Group. So today we are supporting regions like Middle East, Europe, and also Latin America from Bangkok. Roughly, we have 80% of the staff in Thailand are from Thailand, and the 20% are remaining are from different nationality, bringing different experience. So in terms of LRT system, I wanted to maybe share about, okay, what is LRT, what are the different advantages, in terms of system, how do we break down also the different components, and also share also some experience about operation and maintenance. So first, objective of an LRT system, I'm sure many of you know these pictures about the representation and the comparison between cars and without cars and a tram for transporting, for example, 200 people. So 200 people, if you see the picture on the left, is about 177 cars average, and it's represent quite a major traffic. Obviously, on a light rail train, you can see on the right, if you put this same amount of people, in terms of footprint and I would say transport capacity, it's making a big difference. So the objective of a LRT system, obviously, is to reduce the number of cars in the city. So meaning reducing the pollution, reducing the impact on the noise, and of course the time for people to commute from point A to another point B. So it will also improve, I would say, the quality of living in the urban environment in terms of accessibility for people moving, and in terms of social and economic, obviously. Transport quality, and it will be improved in terms of reliability, speed, comfort, and capacity. Also, what is important, it's in terms of the city image, it will improve, obviously, the image and the iconic, I would say, image of any city developing a light rail versus having only car in the area. One thing also from a light rail perspective, it offers PPP opportunity in terms of how for delivering this kind of project. In terms of characteristic for segregated systems, so obviously you can see on the two pictures, with the segregated system we can increase speed for the transport. It will give also priorities in terms of traffic, so it will be more reliable in terms of timetable for the tram. In terms of capacity, also will improve the headways, and also we can provide a longer vehicle on a segregated corridor. Again, in terms of attractivity, it's more accessible, silent, and it's part of a network in terms of connectivity. Also, what is interesting to acknowledge in terms of energy efficiency, to compare tram with bus, diesel bus, and also electrical bus. So some study for comparable, I would say, capacity in terms of passenger transportation show that energy in terms of tram is still more efficient per passenger versus, of course, diesel bus. You can see the graph in the middle in terms of energy consumed for acceleration energy or cruise energy, and also for electrical bus. So this can be explained mainly due to the coefficient of resistance comparison between a steel wheel on steel rail with a tram and rubber tire on roads. So in terms of energy, again, that's the point that I think we need to bear in mind when we look at mobility and transport planning for Thailand, also with a target of decarbonation and energy efficiency. In terms of European tram benchmark, so you can see here on the slide the different characteristics in terms of the rolling stock, non-polluting, comfortable. It's quite large usually. We have also fast and frequent and reliable because we use mainly a dedicated corridor in the different cities. We have, so it's quite accessible in terms of a platform for passengers of any with any disability, because we use low-floor vehicle. Also, it will minimize the civil infrastructure for stops. It's quite also integrated typically in a urban landscape in terms of the street arrangements and also the overhead catenary when we use overhead catenary for the tram. We have public address system obviously in different tram stops, and typically in Europe also is quite connected with other transport modes. In terms of ticketing, we have cities using the same fare collection system from a tram to a metro to a bus. In terms of typical components, so we can break it down into three components. The first one is infrastructure, which can be fully or partly segregated, and we can have any type of, I would say, infrastructure in relation to the tram. Can be at grade, can be underground tunnel, can be elevated. Second component obviously is a rolling stock, which will determine the capacity, the performance, the comfort, also the way we'll have the image of the city reflected through the design of the tram. And then we have the rail systems with, which will provide the information, the telecommunication system, mainly traction power system, and the track and signaling. In terms of rolling stock, so typically the rolling stock manufacturers, they can propose many type of design. You can see a different image here which show a completely different design, obviously. The particularity of a rolling stock I will show here, it's typically for LRT consists of modular sections. So it's quite easy to, I would say, extend the capacity of a fleet by adding several modules when the operator or the concessionaire of a line decide to increase because there is increased demand. So it's a modular composition. As I said earlier, it's a low floor, so you can see on the picture in terms of access for the people, it's quite straightforward. There is no risk of gaps. It's a guided system with a track, and it can be again in terms of design, and you can see the different icons in terms of the cabin, of the cabs. It can be tailor-made for the need and the test and what the client wants. In terms of modularity, yeah, as I said, so can go from short tram to longer tram. So typically, 20 meters is roughly the length of a basic tram. And by adding different modules, as you can see, we can pass from 20 to 30 or even 40 meters. Of course, increasing accordingly the capacity of passengers. So we can go from 140 passengers per tram to up to 300 passengers, for example. In terms of infrastructure, so the station can be decided in terms of integration in the cityscape, depending again on the city, I would say, environment and the will of the people living there, the politics. In terms of, we want the station to be very visible, so you have the choice. For example, here you can see on the first picture, everyone can see the station from far. Or it can be very discreet, just a flat platform with not even one canopy here in this example you can see on the right side. In terms of accessibility, so there is several, I would say, options that can be, again, we can play around, again, depending on the physical constraints and the city itself. So you see, for example, on the right, the different cities of Birmingham, Lyon, and Nice, with the different type of arrangement, or is it integrated? as I said, again, the access between the platform and the tram, because it's a low floor, is quite straightforward. We have some typical, I would say, constraints in terms of gradient, but it's quite, I would say, flexible in terms of gradient in stations. And for access ramp also, we can put access ramp on the side. You can see on the graph at the bottom to have people with, for example, disability who can access the platform easily. Again, station accessibility, some example. We can have a ramp also coming out from the tram. So in terms of operation, what is often the challenge, I would say, it's interaction between the tram and pedestrians, because the track is embedded and the system is embedded into the urban environment, and people can cross the track if it is integrated with the roads, like we can see here. So this is important to acknowledge. In terms of system, we have different also approach that we can implement. There is, for efficiency of operation, obviously the traffic priority is the best approach for tram system, meaning that when there is a road crossing with the tram, then there is a system of signaling with mass detection, typically, that will trigger the road traffic to stop the car traffic, and then having the tram arriving prioritized. Then that will help for the mass transportation. Typically, we have one OCC taking care of the full network of the full line. For security, we have like a metro lines CCTV system. We have also we have a PA display, etc. And for passengers, so access control, ticketing, so it can be made on any type of control. Can be at the tram stop, can be on board of the tram. In terms of environment, so it's quite friendly, zero emission. It got a limited noise and vibration impact on the environment. And typically also we have technology or techniques to have also, if we use overhead catenary, to have a specific design to integrate the overhead catenary into the environment. Or even now we have also solutions with no overhead catenary on batteries or with a charging point, or having feeding electrical system through the ground, like in Bordeaux in France. So here you have different, I will say again, configuration and cities mainly in Europe. And you can see the one on the right, bottom right, from Bordeaux, which is from Alstom, where there is no overhead catenary and the electricity is fed from the ground. So in terms of typical urban integration for the track itself, track corridor, so we have I will say in a summary, five typical options that will show some example. And again, here you see the different, just for information, so the one in Saragosse, it's on battery with a charging station at the tram stop, so no catenary. And again, the one underneath is from Bordeaux with no catenary and power through the ground. So axial track, I would say it's maybe the preferred one, depending again on what can be done physically in the city. It provides a good commercial speed because it's like a segregated and corridor for the tram. It's the pedestrians are using, I would say, the sidewalkway on the other side of the road, so there is less risk of pedestrian crossing, etc., and walking on the track. It's easier also for the organization of the maintenance and the operation of the system, again because of the segregation. And it's an easy flow of the different road users, because for crossing it's more straightforward with a crossroad. When you have lateral tracks, so it's the both tracks on one side of the roads. So this can be okay, I would say, if you have for the car traffic one way, it will be better. It's also feasible and easier if you don't have too many private access on the site. And one of the inconvenients, you will have to be low speed because again you will have pedestrian walking next to the track. Then you have bilateral track options, which is not very ideal for operation because you have to operate and access for the maintenance to separate tracks. It's possible where you don't have, again, too many private access on both sides of the roads. And again, same than before, you will have a lower speed than segregated corridor because of pedestrian interaction. Then you have the on-street track that sometimes we cannot avoid. It's where you have the mix used between the car and the tram using the same corridor. So on this configuration, you are, I would say, like a bus. You are dependent on the road traffic. So you will have, it's good when you have a low car traffic, otherwise you don't have the advantage of the tram anymore. And again, the speed will be very lower because of this interaction with the cars. And you have also the pedestrian on the side. And finally, split tracks. So it's very rare, but it can happen. It's where you have physical constraints in terms of, again, space for the corridor, and it's not possible to have the two tracks running in the same street. So it can happen. It's not ideal, obviously. It might be a solution when you have very narrow streets. It's more expensive because you will have to build the system on two different streets. So you cannot, I would say, optimize the works. It's like two sites, and not ideal for operation again. Also, I wanted to share with you some figures and some also experience on CapEx and OpEx for tram. So here you can see, based again on French cities, okay, for trams, a typical cost breakdown between the different activities. So what can be noted, first thing which comes to the eye is 1/4 of the cost for the CapEx is related to the rolling stock. Of course, you have also the one important cost center, I would say, which is the civil works, including the track beds and the utility relocations. In Europe, so where we have, I would say, all cities with a lot of utilities in the ground, when you build a tram, you have to relocate the utilities. And depending on how these utilities have been built in the past and recorded on drawings, it can be very challenging in terms of the construction. And I know also, for instance, that in Australia, for like cities like in Sydney, for the Sydney Light Rail, for example, there were major challenge related to utility relocation in the city, especially in George Street in Sydney, because of a lack of accurate information. So I would say for city in Thailand, when it's all cities, it will be a challenge. because in terms of records, I'm not pretty sure about how it has been recorded in the past. But for new cities, greenfields, that this aspect will not exist, so that will be also an optimization. So I know, for instance, for EEC, the Eastern Economic Corridor, where you have there is plan to build some smart cities and with mobility solution for people. That might be also a good solution to look at tramway. Then, in terms of tram type, we can summarize in four types: conventional, short, economical, express. And you can see on this table, I won't go through it in detail, but it's like a shopping list. Again, depending on what is the main criteria for the customer in terms of urban integration or building or interstation distance, vehicle capacity, headway, or cost per kilometer. Then depending on, again, the priority of this type of criteria, the client can look and I would say, again, like a shopping list, say, okay, I want my cost to be the minimum, then I will look first at maybe an express mode or type. Or if I want a full urban integration, so maybe we'll look at the conventional or short. And after he will, that's the idea really of this table, is to see what criteria will imply what type of system and what will be typically the impact. In terms of operation and maintenance, typical organization, so typically it's three pillars, one related to management, shared function or transverse function, like human resource, health and safety, environment, financing, legal, etc. One pillar related to operation, so with the control center, management, the ticketing, and all the security. And one related to the maintenance, with different teams for the different type of system for the maintenance of the system. And here I wanted to show you an example, which is for Parramatta Light Rail in Sydney, which consists of 12 kilometers of dual tracks, 16 stops. They have overhead line equipment with some free zone of catenary free zones. It's a 44-meter long vehicle. There is one depot, one OCC. There is a backup. And you see the organization chart of the operation and maintenance concessionaire. So you find again on the right the operation management, the pillar operation management. There is after right from left, so the maintenance pillar that here is called head of asset management with a team for the different maintenance of the system and infra. And then I would say the other, soft skill or soft organization related to the HR, safety, the customer relation, and the commercial, including the finance, etc. In terms of operating costs, so we can, let's say, break down into four main aspects. The first one is related to the personal cost. The second one for the spare parts, the supply, and the insurance. And third one, energy. And the fourth, structure costs. To be noted that in France, the average operating cost for a tram is around 7-8 euro per vehicle kilometers. Now, in conclusion, I wanted to emphasize on 5 pillars or the 5 key success for implementing a tramway in Thailand. So the first one is in relation to government support and policy alignment. And it's where I think it's important to have an organization like RTRDA today that is there also to harmonize and coordinate between authorities and private sectors to have this type of alignment. So this shall ensure in terms of proper process, proper standard, robust standard for tramway, proper process for the procurement, also in terms of land acquisition, land use. So all this type of, I would say, policies that needs to be defined in advance. Second one is related to have an early engagement with local stakeholders. So mainly to have the support of the politics, and also that the public, the people living in the city are also willing and buying the tramway system. Third one is to have a comprehensive integrated planning. And of course, we have feasibility study, a process, etc. But really looking at a city is to look at the different poles of attraction. It can be a specific business center, commercial center, can be an hospital, can be universities, and see how to connect all these different points and make the system attractive for the population to make their life, I would say, better in terms of commuting, and then having the revenue also for the system. Fourth one, is to have an effective project management in terms of designing and building such projects. And the final one is also to develop local competency, typically, again, with a manufacturer from international background, engineering company, to have a connection with local university, local I would say schools, to ensure that we develop the local competencies. Then we have, I would say, the local people who can also operate and maintain the tramway in an effective manner for the future. That's it for me, and I would like to thank you again for your attention. Thank you.
Thank you very much, Mr. Philip, for your valuable presentation on tramway system and operation.
Okay, last but not least, let's move to our final speakers. We have Kun Khajon Siwarangsan, Head of Rail Ecosystem Business, West Coast Engineering Co. Limited, who will discuss on the topic, the dynamic of railway services capability of West Coast Engineering. So everyone, please join me warmly welcome Kun Khajon on the stage, please.
Okay, good afternoon, everyone. My name is Khajon Siwarangsan, Head of Engineering Business of West Coast Engineering Company, WCE. This session, I would like to present you in the topic of the dynamic of the railway service capability of West Coast Engineering. Prior to talk in detail about capability and dynamic of WCE contribution to the Thai railway industry, I would like to introduce WCE Master Company, our group company first. Our group company is the Asian largest flat steel producer named SSI Group. There are 6 companies in the group: PPC, Prajwap Port companies doing the deep sea port business, SSI, Sahariya Steel Industry Public Company, is the mother company of the WCE and doing the hot roll steel business. TCRSS, Thai Cold Roll Steel Sheet Company, doing the cold roll steel business. TCS, Thai Coated Steel Sheet, doing the electro galvanized steel business. SPM, Sahariya Plate Mill, doing the steel plate business, and SVL Corporation Company, doing the transportation business. For all of this business, WCE is the engineering solution company, provide services to the group. WCE established in 1999 with the currently registered capital 120 million baht. We are a sister company of the ASI. We provide the quality engineering services, including machinery engineering, maintenance management, steel fabrication engineering project, robotic automation, and rail engineering. Our philosophy, vision, we will be the leader of engineering innovation. Our location, we have the head office located in Bangkok, and we have 2 sales offices, one in the northeast Khon Kaen and another one in the west Ratchaburi, and our factory based in Prachuap Khiri Khan. We are the engineering company, so we got many international standard quality related for our business, such as ISO system and ASME URS stamp and JSSCM for steel structure. We have 6 business units: mechanical fluid and electrical services, machinery services, fabrication services, engineering procurement and construction EPC service, rail engineering and robotic and automation. Okay, we will show you what we can do and what we have done. For the NFE service business unit, we provide skilled technician, supply and services for preventive maintenance, product corrective, and emergency of maintenance engineering with highly skilled technicians and experience with certificate of competence of the work. We have the experience more than 22 years. There are 2 models of the MFE services we can provide. Maintenance contract. This is a long-term contract. For example, 1 year or 2 years. Which kind of skilled people do you need? How many people do you need? Then we provide you including with our maintenance system management. Specific maintenance like a short-term period such as emergency or annual shutdown maintenance job service. This is an example of the maintenance contract for Sahariya. We provide 1,500 man-day. This is another example maintenance contract for Siam Craft Industry. We provide 300 man-day manpower. This is an example for the specific maintenance major shutdown at the Phoenix Paper Public Company. They need 6 skilled people during the major shutdown. Okay, next, machinery business unit. We provide engineering, design, repairing, upgrading, and manufacturing of machinery and components related to mechanical fluid and electrical field, as well as inspection, measuring, testing, and instrument calibration. With our experience more than 22 years in variety of industries such as steel, energy, cement, paper, chemical, and food industry. For the repair and overhaul services, we have specific and general repair and overhaul. The specific need the specialized knowledge and experience of the people. Example of the specific repair and overhaul. In the picture, this is a mandrel gearbox spindle used in steel industry, rolling mill. Example of the repair driving gear by joint welding for sugar industry. For the industrial part supply, we have the high accuracy CNC milling, boring, engraving, and lathe machine capable for making and develop the industrial part, as well as our knowledge to do the reverse engineering, to be your partner as a OEM or develop and innovate the industrial part. Fabrication services BU. We provide engineering design, manufacturing, fabrication, and installation of steel structure with more than 15 years experience with the international quality. We have full fabrication facility with totally capacity 3,500 tons a month around Thailand. Some of the job that we have done, this is a reference photo. For example, build-up beam we export to Japan, rail steel bridge, fan casing export to Taiwan, parabolic antenna. This is the biggest in Southeast Asia. Steel bridge in Pisanulok. This is the first arch bridge in Thailand. This is a parabolic antenna, diameter for 40 meters. This is the biggest in the Southeast Asia. Our client is a German company. Erection, installation, and commissioning by WCE. This site is located in Chiang Mai. And this is a steel bridge for the railway in Thailand, 56 meters length. Inner cover for the batch handling process. This is a diameter 1.6 meters stainless steel material. Fan casing, big fan used in power plant in Taiwan. Factory stacks, 60 meters high. And water pressure tanks diameter 2,000 millimeter. Okay, next, EPC project service business unit. We provide engineering design, procurement, construction, installation, and testing services, EPC contract project. We support clients to develop framework to ensure they invest the right project and execute effectively, time, cost, and quality. Our project execution service, engineering, construction, procurement with the project management. More than 15 years experience in the project. There are 4 sub-products of the EPC service: solar energy, steel bridge, industry, and pipe. This is example from the solar energy. Solar rooftop capacity 650 kilowatt peak for factory. And this is another solar rooftop capacity 100 kilowatt peak for hospital. Steel bridge. This is fabricated by our fabrication BU and project management by EPC BU. Example for industry, mechanical erection work for the machine. Co-warehouse and handling system. Turntable and loading arm. This is the first machine in Thailand developed by WCE. This machine using for lay down the big power cable under the sea. The price less than a half comparing to import from Europe. Okay, this is a parabolic antenna, fabricated by our fabrication BU and project management by EPC BU. Robotic and automation BU. We provide unique services of robotic and automation technology and innovation. Over than 15 years service to the customer in the manufacturing industry. We delivered the service of system integration from concept to implementation and completion. What we can deliver are welding robot, field instrument, computerized gauge, drive, PLC, HMI, SCADA, obsolescence management, ASRS, and SEMS. Example for the welding robot. This is an application for transformer tank. And this is also welding robot application for the blower. This is a project in SSI UK. We enhanced the slab slitting machine at the SSI UK. The automation system of this machine obsolete. We revamped the system both of hardware and software by Thai people. In addition, we add more measuring sensor, so improve the accuracy of the slitting process, reliable of the system, end up with the success of the production yield loss reduction. Another example in inside UK for the automation solution. Skimming vision system for the desulfurized station. At the desulfurized station, the operator have to skim the sulfur slag. It is on the top of the hot metal, you can see in the picture. We apply the vision technology to optimize between steel quality, yield loss, and the cost. Okay. The last one, Rail Engineering Business Unit. This is the new business unit of the WCE. We start the business development with our passion, our belief, and confidence that with our capabilities and experience of all our engineering services, WCE could contribute something, not big, even a little thing, but it should enhance or promote the railway industry in Thailand. This is what we believe. This is the development timeline. We start the development during 2017 to 2021, and then we have this product as a business unit in 2022. During the 2017 to 2020, we did the recondition of the tail suspension of the GA locomotive and bogie frame of Alstom locomotive. In 2020, we decided to develop the prototype of the container freight wagon, 2 cars. We call them the Thai Eye. In 2021, we provide a yearly maintenance service contract and repairing the wagon steel structure to SRT. In addition, we invest for wheel pressing, mount, dismount, bearing machine. The freight wagon we have done and passed the running test 2023 this year. And the production standard and the running test, we follow standard and regulation of the SRT. We believe that our freight wagon product would be ready for the commercialized next year. And the new model, next model, we would like to develop the lightweight prototype around 2025. Okay, this is a yearly maintenance contract for diesel multiple unit. We provide 15 skilled technicians to SRT Makassar. And this is a recondition of the tail suspension for GA locomotive. It is a showcase for us. SRT has already write off this tail suspension. No one can repair it, but we did it. Also, the bogie frame of the Alstom locomotive already write off, but we did it. We condition of the axle and wheel. We use our skill and experience for the machinery repair. Also for the gas carrier structure. And this is a transversal 120 tons. This is our EPC turnkey project we provide to Makassar Depot. Repair and refurbish passenger coaches. This car is got an accident and we rebuilt it. Linkage, the wheel set of the track tamping machine because our customer bought the second-hand car and then they have to linkage the wheel. And this is a bogie container freight wagon prototype. We produced 2 cars already. One car we use the standard 3-piece bogie according to SRT standard. Another one we apply self-steering bogie. This is the first technology we apply in Thailand. With the specification 20 tons axle load, meter gauge, and maximum operating speed 100 km per hour. This picture you can see that we have a static load test, and tomorrow section C1 rolling stock we will talk in detail about the testing and measuring technology. Okay, this is a running test we done on 11 May this year. We use Viya product as a load test. We put inside the container. The length of the test around 300 kilometers. Engineering department from SRT witnessed the test. Okay. Oh, sorry. Okay. This is an example of the accessory we did on top of the freight wagon to capable for steel hot low coil transportation. Our group company willing to ship the mode of the transportation optimized between on the road, on the ship, and the rail. We have the steel product to transport more than 100,000 tons a month. This is the next step of our WCE to support our group company. Okay, that's all for me. Thank you for your attention.
Thank you so much คุณขจร ศิวรังสรรค์ for your insightful discussions.
We have come to an end of the day. As we wrap up today's event, let's take a moment to reflect on the wealth of knowledge we have gained throughout the day. It's been truly enriching experience, and we hope you have gained valuable insights from the speakers and sessions.
Now, as we conclude this event, please join us for the conference reception taking place off screen. You can explore and gather more information from our sponsor and partner booth until 5:30 p.m. And we're going to move to the private banquet dinner at the Lotus Suite, which is located on 32nd floor. Please note that it is for the ticket holder only. Our sincere appreciations go to Bentley System and Design, Huawei Technologies, West Coast Engineering Co. Limited, whose generous sponsorship has been cornerstone of today's event.
And a sincere thank you to our esteemed hosts, including Rail Technology Research and Development Agency, Ministry of Transport, Hub of Talent, Thailand Railway Research Network, Ministry of Higher Education, Science, Research and Innovation, Bangkok Expressway and Metro.
Thank you once again to our honored guest, Chief Inspector General of the Ministry of Higher Education, Science, Research and Innovation,
Chairman Board of Directors of the Rail Technology Research and Development Agency,
Permanent Secretary of the Ministry of Transport,
Chief Transport Research and Policy Section, UNESCO.
And to all our participants, both on-site and online, we bid you a fond farewell and hope to see you again at future events. And with that, we officially conclude the first day of RRTC 2023. Have a wonderful evening, everyone. Thank you and สวัสดีค่ะ
ขอบคุณครับ